What is distribution and why it is important in statistics? So we will start with a simple example. Let's say we have a small data set and we want to describe this data set to someone. Now, when I say describe, that means we want to give an idea to the person about what kind of values our data set ha has and what is the frequency of those values. So what we did, we plotted a bar graph, and this bar graph showing the frequency of each of the values. So for instance, 12 is occurring 8 times and so on. Now the thing is, if that person doesn't know the size of this data set, telling him that the 12 is occurring 8 times doesn't make any sense, because it will not give him an idea what portion of the total data set this particular value is having. So what we did, uh, we divided the frequency of each of the value by the total size of the data set. So here we have 18 numbers. So we divided each of the frequency by 18. So 8 divided by 18, which is less than zero point 0.5, and we come up with this plot. So we have plotted our data using this one, and here it's showing that 12 is occurring more than 40% of the time in the data set. Or in another term, we can also use this quantity as the probability. So we can tell the probability of seeing a value 12 in the data set is more than zero point 0.4 or more than 40%. So how the probability is computed? So if you want to compute the probability of 12, just check how many number of times 12 is occurring in your data set and then divide it by the total number of data set. So this probability plot, it will give you an idea what's the probability of each value or what's the portion of time that value is occurring. So such plots actually helpful in understanding the data. Now coming to a real case, now just assume you have data set of sleeping hours of 1,000 people. So these numbers might not be seen to you, but let's say these are like 8 hour 50 minutes or 6 hour 30 minutes. Now when you have such a large data set, understanding this data set is really difficult. So if you show that entire data set to the person, he might not be able to understand. It doesn't make any sense. Now we will switch to our previous approach. We will plot this data and we will plot it with the probability. So we come up with this visualization. Now here uh, the visualization is plotted, and the most of the values are somewhere here between 6 and 8, and it means that most of the people have sleeping hour of 7. So this actually plot help us to understand the occurrence of the value. So here if we look at, there are very few people who slept in the range of 0 to 2 hours, and same here, there are very few people who slept more than 12 hours. So this kind of plot actually help us to understand this entire data set. And if you see this shape, if you see this bell curve shape, that means your data set is following normal distribution. Now I'm sure that you heard this normal distribution while studying statistics and why it is important. So we are going to see it in next slide. So, so when your data follow a normal distribution, your entire data set can be summarized with only two parameters. First is mean and second is standard deviation. Now what does that mean? Like how our entire data set can be summarized with these two parameters. So, so let's say now you are interested to know how many people are sleeping more than 5 hours, or how many people are sleeping exactly 5 hours. Now, if we have this plot, we can check that manually. If we have this entire data set, we can count how many number of people are having 5 hours of sleep. But how we are going to compute that with these two parameters? So if your data is following normal distribution, we have a formula, and this formula require only two values. First is mean, the second is, this is actually a variance, this is a square of standard deviation. And when you put the x, like for which you want to know the probability, so we want to know the probability of 5 hours, so you just plug in all these value in this formula and it will give you the probability. Now we are not supposed to do that, because nowadays almost all the tools have this inbuilt functionality. You just plug in the value and it will give you the probability. So the thing is, all of your questions about the data set can be answered using these two parameters. That means need we don't need the data set. So here, if we look at the our plot manually for the 5 hours, the probability is somewhere around more than zero point 0.1. And if we plug this value x, mean of the our data set, standard deviation of our data set in this formula, we will get the same probability. So that's why this if you can find out that your data is following some distribution, your entire data can be summarized with few number of parameters. And if your data is having a bell curve shape, that means this is a normal distribution. And most of the natural phenomena, like if you collect the data of heights, if you collect the data of salary, it will be following normal distribution. There are cases that it's not exact normal distribution, there is some skewness, but still, if you can find out that your data is following normal distribution, that's it. Like you are good with only these two parameters, and that's why identifying the distribution is very helpful. And one another important thing about the normal distribution, let me okay so here, when we want to know the probability of a particular value, so we want to see what's the percentage of people who are sleeping exactly 5 hours. So in this curve, the value somewhere here, which is more than zero point 0.1, is our answer. But if we want to find out how many people are sleeping, let's say less than 5 hours, or let's say more than 5 hours. So in case of less than 5 hours, we have to compute this probability for all these value in this left side from here to here. And if you want to find out how many people are sleeping more than 5 hours, in that case we have to compute the probability for each of the values in the right side of 5, and we have to add their total. We have to uh, sum all those values. Now we don't need to do that manually, and we have formula for that. And in the same regard, if we compute, if we subtract one standard deviation from our mean, and if we add one standard deviation, so the range of the data we will get, that range of the data will contain 68% of data. What does that mean? So the meaning of that, in your distribution, most of the people will lie in from this reason, and that reason in normal distribution we call like one standard deviation plus and minus. And what's the percentage of those people? 68.3%. Now if you subtract two standard deviation and add two standard deviation in the mean, the range you will get, that range will cover around 95.5% of people. So for instance, if someone asks you from this data set like how, like what's the sleeping hours of 95% of people, what's the sleeping range, so what you can do, you can compute the mean, you can compute the standard deviation. Now then, in the mean you add double of standard deviation and you subtract the double of standard deviation, and the range you will get, that range you can report as that 95% of people are having sleep hour between this range. So this is actually very helpful in case of normal distribution. Thank you very much for watching this video. In next